For over 40 years, our passion has been innovation. Innovation which we enable and those which we drive ourselves. One of the latest LPKF innovation is our breakthrough light technology for ultra-precise glass processing. It has the potential to revolutionize multiple industries, starting with our own. Today we are presenting a game changer for laser material processing, LPKF's Tensor-Technologie. Tensor-Technologie solves a fundamental problem that has long constrained the progress of laser microprocessing. Looking at the development of laser sources, we see that for the same cost you get more and more power. This is great. The problem with more power is finding a way to use it meaningfully. At the beginning, processes could be accelerated linearly with more laser power. However, this is no longer possible without losing quality. We have reached a point where the actual processing speed is limited much more by the beam steering technologies than by the available laser power. This is exactly the point at which the Tensor-Technologie gets into action.
The solution is relatively straightforward. If the laser radiation is moved more quickly, the energy of the laser is better distributed. Heat accumulation as well as losses in quality are less likely. In other words, you can operate with much more power before these effects occur. However, faster beam steering is easier said than done. Standard galvanometer scanners have reached the end of their speed development. All other approaches, such as AOM, EOM and polygon scanners, are associated with considerable disadvantages, such as low efficiency, high cost, poor beam quality and a lack of flexibility. We have long dreamed of implementing our Tensor concept. Thanks to our light technology and in-house manufacturing infrastructure, this dream has finally come true. Our highly flexible development capabilities enabled the implementation of this beam steering system in record time.
Tensor overcomes the technical limitations of conventional solutions. It can be integrated very easily into different systems and adapted to various applications. By combining Tensor with the galvanometer scanner, we can achieve much higher speeds of beam steering without losing any flexibility. The beam velocity is 4 times higher than that of a galvanometer scanner alone. Furthermore, Tensor can be used for a wide range of lasers with almost no energy losses, even for ultra-short pulse lasers. The initial results with Tensor were remarkable and exceeded our expectations. The process time improved threefold, which could only be achieved with this technology. We are witnessing the dawn of a new era for laser micromaterial processing.
Make no mistake, the problem solved by Tensor-Technologie is everywhere in laser material processing today. This is a breakthrough innovation. Ultimately, the use cases are not limited to our current product portfolio. Nevertheless, we will of course start from there. Ladies and gentlemen, we are incredibly proud to also launch the first LPKF laser tool with Tensor-Technologie today, the Cutting Master 2240. As the newest member of our award-winning Cutting Master series, it takes laser depaneling to a whole new level.
For our customers in the SMT assembly market, the separation of PCBs from the panel is a crucial production step. Technical requirements for cleanliness, precision and flexibility are constantly rising with the growing complexity of electronic designs and miniaturization. At the same time, the system's cost-benefit ratio must hit defined economic targets and business cases for capital goods. Consequently, cost efficiency always goes hand in hand with technological innovation. Today, the technical predominance of laser-based routing compared to conventional mechanical cutting is undisputed. In recent years, we've seen constantly growing recognition for laser systems in the SMT market. for example, in the automotive and medical sector, followed by other major industry verticals. In the early days, laser cutting was considered expensive against mechanical solutions. Over the last decade, LPKF improved price-performance ratio by a factor of 10, catching up with traditional solutions. Today, I'm proud to announce we can put even more on top with our Cutting Master 2240 and Tensor-Technologie. This innovation will allow us to revolutionize laser depaneling in the major segments, like conventional 0.8 to 1.6 mm rigid PCBs. With increased power source and tensor, we achieve 4 times faster cutting speed compared to our predecessor. By this increase in processing performance, customers will benefit from improved energy efficiency, supporting the reduction of their carbon footprint.
For the new Cutting Master 2240, we equip our most compact laser depaneling system with the most powerful laser source we've ever used for this application. Compared to previous models, the laser power has been increased by 25% to 40 watts. With the design based on industry-proven LPKF laser sources, we further improve durability and robustness at even higher power levels. This has significantly reduced the total cost of ownership by up to 40%. To allow our customers to fully benefit from this extra power, we have installed our breakthrough Tensor-Technologie in the Cutting Master 2240, setting new standards for the technical clean cutting of rigid PCBs. We can see a reduction of cycle times by up to 70%.
Tensor-Technologie is a game changer for micromaterial processing. 10 times faster beam velocity, almost no energy loss, transforming all the laser power into higher productivity and quality. LPKF enables innovation.